The solution to this problem is to construct what's called a spanning tree, which is a loop-free topology that covers every node in the graph. The set of edges shown in blue constitute what's known as a spanning tree. The collection of edges in the blue topology covers every node in the underlying physical topology, and yet there are no loops in the blue topology. Now, instead of flooding a frame, a switch in this topology would simply forward packets along the spanning tree. So for example, this switch would only send a frame along the port corresponding to the blue edge and would not forward the frame out any edges that were not part of the spanning tree. Other switches that received the frame would flood in the same fashion, along all edges that were part of the spanning tree, while omitting edges that were not members of the spanning tree. Let's take a look at how to construct a spanning tree. First, the collection of switches must elect a root, since every tree must have a root. Typically, this is the switch with the smallest ID. In this case, the switch at the top of the topology is the root. Then, each switch must decide which of its links to include in the spanning tree, and it excludes any link if that link is determined to be not on the shortest path to the root. For example, let's consider the switch in the lower right. It has 3 links. This link takes it on a path that's 3 hops from the root. This link takes it on a path that's 2 hops to the root. And this link takes it on a path that's 1 hop to the root. Any link that's not on a shortest path to the root is excluded, and any link that's on a shortest path to the root is included. Similarly here, this edge is on a path that's 1 hop away from the root, and this edge is on a path that's 2 hops away. So this node will exclude this link from the spanning tree. Now each switch repeats this process to exclude links from the underlying topology, and ultimately this yields a forwarding topology that looks like the blue graph. Now of course, there's an issue, which is how do we determine the root in the first place? Well, initially, every node thinks it's the root, and the switches run an election process to determine which switch has the smallest ID, and if they learn of a switch with a smaller ID, they update their view of the root, and they compute the distance to the new root. Whenever a switch updates its view of the root, it also determines how far it is from that root, so that when other neighboring nodes receive those updates, they can determine their distance to the new root simply by adding 1 to any message that they receive.